Okay, on this lecture, I want to go over this diagram here. It's a little bit more in-depth and added a couple more components to a typical gas-fired furnace. We have a little bit more of an in-depth look at our thermostat. We have our blower motor. We have a fan limit switch. We have a relay, emergency switch, transformer, and gas valve. Okay, so where do we want to begin with this? Well, we want to think about, again, 120 volt circuit. Always try to wire and think about your wiring diagrams from the top down. 120 volts. So we have L1 in neutral, we have an emergency switch. You could always think of the emergency switch as the switch that's at the top of the stairs in the basement that we can automatically shut off in the event of an emergency, which some cases some people do for mistake for a light switch and accidentally shut off, and in the middle of the winter they have no heat. You go out and that's basically all the problem was, is because the emergency switch at the top of the stairs was off. So in order to wire this, we are going to start off with L1, and we're going to come down and we're going to wire our emergency switch. Okay? Out of that emergency switch, we're going to go in a couple of different directions. Okay, we need to wire up the relay. We need to wire up our fan limit switch. Okay, so, and we also need to wire up our primary side of our transformer. Okay, so let's take care of that first. Let's do out of our switch. Okay, let's come on over. Let's wire up our primary side of our transformer. Okay, we're going to come over here. We're going to use a light blue. Oops, sorry, we're going to change that back. Let's change that to black. Okay, and we're going to come over here and we're going to finish that circuit for our transformer, just like that. Okay. Okay, so there's our very first circuit that we need to deal with. Okay. So we're bringing it out of the emergency switch into the primary side of the transformer. Again, always remember, try to wire all of your wiring diagrams, everything from the top down. Okay, so the next part that we're going to look at, we're going to look at the relay. Okay, the relay here is our blower relay. Okay, so what we have here is we have terminal 1, 2, and 3. Got a normally open between 1 and 2, a normally closed between 1 and 3. Now, if we look at our blower, we're going to see that we have a low speed and a high speed. Okay, when we are dealing with a furnace that has heat and air conditioning in it together, we want to be able to control fan speed. Okay, typically when we are in heating, we always want the fan to be in a low speed. Okay, we don't want the air to be moving too fast through the system and into the space, because we can actually start creating a draft. Okay, people will start feeling like a drafty feeling, and you get complaints and stuff like that. So we want to actually take the fan speed and make sure that it's on a low setting. Okay, we want it to move, but we don't want it to move too fast. So we need to wire our fan in such a way. Okay, so in heating, our relay is normally going to be de-energized. It's not going to do anything. Okay, it's just going to kind of just sit there. So really, when we're in heating mode, we're going to come out of our emergency switch like so, and we're going to power up our terminal 1 like that. Okay, power's coming in to our relay. We're going to come out on terminal 3. Terminal 3 is normally closed. When we hear that term, normally closed, it is in that position when it is de-energized. Okay? A relay has our contacts and the coil. So in order for that contact to change from a normally open to a normally closed, or from a normally closed to a normally open, our coil needs to get energized. Okay, and the only time that that's ever going to happen is if I happen to throw my thermostat into the cooling mode. In heating, the relay just sits there. It's just another point in the system where electricity has to pass through. So I'm going to take my wire out of 3, like so, and I'm going to bring it down to my fan limit switch. Okay, because now, remember, I'm in heating. Okay, I got to have something in there to control my fan, so it's going to have to be a thermostat of some sort. So I'm going to bring it down, and I'm going to go through my my fan limit switch, like so. Okay. Out of my fan limit switch, I'm going to come down, and I'm going to go to my normally to my low speed, like this. Okay. Like so. Oops, sorry. Okay. Like so. Out of my switch, my emergency switch, I'm going into my number 1 relay, my number 1 terminal on my relay, which is my power. And then I'm sending it out to my normally closed, because again, remember, this relay really doesn't do anything when we're in heating. Okay, it's just a component there that we got to use. So, come out, down, into my fan limit switch, which is, again, just a normally open switch. At 130 degrees, that switch will close, which will now send power down to my low speed blower. And then I'm going to go back to my neutral, okay? And I'm going to use green in this case, just to kind of signify the different wires. Okay, so we're going to come out. I'm going to go up, and I'm going to go back to neutral, just like so. Okay, so there's my circuit for my low-speed fan. Okay, so now what I'm going to do is I'm going to finish my blower. I want to take my wire, and I want to complete this circuit. Okay, so I'm going to do my high speed. Okay, my high speed, I'm going to use orange in this case. Okay, so I'm coming out of number 2. Like so. And I'm going to come down, and I'm just going to simply feed my high-speed winding for my blower. Okay, just like so. Okay. Oop. Come in, and I'm going to feed my high speed, just like that. Okay. Now you'll understand this in a minute once I start wiring the thermostat. Okay. But right now, again, I'm just taking care of the high side, the 120 volt circuit of everything, just so that it keeps me from not getting confused. Okay. And the same thing with you guys. You need to understand line voltage, secondary voltage, 120, 24. Once you have that understanding, wiring of a circuit is really not as complicated as many like to think. So, am I finished with this? Yeah. Believe it or not, I am. I am 100% finished with my 120 volt circuit. Now, I can actually take it to my 24 volt side. Okay, so again, knowing how our circuitry works, I can figure out how my 24 volt circuit needs to be wired. Okay, again, just focusing on our heating section of it all, I want to make sure that I'm able to power up my thermostat. I got to be able to send power to my gas valve, okay? But I also have my other safety. Okay, that's my limit side, my 200-degree side of my fan limit switch. Okay, so just like in previous diagrams, we want to be able to send power down to my R, from my transformer down to my R. Then I'm going to send it out to my my white, out of my heat. So coming out, I'm now going to send it to my limit. Like so. Okay, just like that. Okay, out of my limit, I am now going to send my power to my gas valve. Okay, because remember, the gas valve is what has to be controlled. Okay, it's our heat source. Okay, we don't want it to get out of control. So we got to have some sort of safety in there to take it out. In this case, it's going to be our limit. Okay, just like that. Okay, and then out of my gas valve, I'm going to go. I'm going to go brown or yellow. Okay, and here we go. I'm going to come out, and I'm going to come back up to my 24-volt side. Okay, and here, let's just change that color around here. Well, let's do, yeah, here, we'll do that. That way you can kind of see it a little bit better. Okay, let me just 1 second. Let me just change the color here. Okay, so you can kind of see that differently. There you go. Okay. So there's my 24-volt side coming out of my transformer into my R. Okay. Once I call for heat, I'm sending it out through my W up to my limit. Okay. As long as that limit is closed, I'm going to send power down to my gas valve. My gas valve will get energized, and I'm back to my 24. Okay. So the last thing that we really have to do here is my G or my Y. Okay? When we're in air conditioning, just a little tidbit is that anytime Y is energized for cooling, G automatically gets energized as well. And we can see that right here in this wire. Right here. Got auto and on. Okay, there's that fan switch that you have on your thermostat, auto and on. Anytime Y gets energized and that switch closes, I'm sending power out my Y terminal, and I'm also sending it out through G, just like that. Okay, so what I want to do is, just for the sake of simplicity, I'm just going to wire G in this case, just to kind of show you that if I turn this fan switch into the on position, I'm going to send power up to my fan relay here, which will in turn make these two contacts change position, which means that normally open will close, that normally close will open. Okay, so in order to do that here, we're going to use green. Let's use a nice green for this. Okay, come out. And I'm going to come straight up, like that. Come in. Okay, and then all I'm doing is I'm coming back out of that coil, right back to my 24-volt coil, just like this. and back down. Boom. And that's how this is wired. It looks a little messy, but hopefully it will give you guys a little bit of an understanding, or anybody that watches this video, a little bit of understanding of what is actually going on in a typical residential, maybe light commercial type application. Again, this circuit here does not have any electronic ignition devices yet. We're slowly making our way into that, but this is just a more in-depth look at what our circuitry is actually doing in a particular application. So again, that's basically all this is. And I hope I've cleared up some stuff for you guys. Talk to you later.